Hello everyone, and welcome to a new video. Today we're going to dive deep into everything related to state management and applications. We'll cover it from A to Z, comparing server state, client state, modular state, global state, and local state. Basically, everything you need to know about state management. This is a theoretical lesson aimed at expanding your general understanding. So let's get started. Working with data is the key factor in why we build applications in the first place. We store data, we process data, and we visualize it. This is the core purpose of any application. Everything else is just bonus features and additions. Take Instagram, for example. It stores photos that are uploaded by users, user profiles, stories, follower lists, likes, comments, direct messages, and much more. Obviously, this data is stored somewhere on a server in a database, and the server in this case serves as the single source of truth. On the client side of the application, the front end, things work a bit differently. Here, user sessions are short-lived and can be interrupted at any moment. You simply press F5, the page refreshes, and data is lost. That's why we work with the client-server model. The client continuously sends data to the server processes it somehow, and returns data back to the client. It's a standard model, but year after year, modern front-end applications are becoming increasingly complex, and we have to work with huge amounts of data within a single session. So how do we work with this data? Essentially, the main task it all comes down to is maintaining consistency between the data we work with and the UI that renders this data. To understand what consistency means, let's look at an example. In our code, we have this little script where we display a product's availability status. In our data, we might have in stock written, but in the UI, we might be rendering out of stock. This is a standard situation in front-end development when data and UI are not in sync. And this is exactly the problem we need to solve. There are many ways to synchronize this data with the display, and the main and most commonly used approach is state management, managing the application's state. Let's imagine state as a big warehouse that represents storage for the very data on which the application's logic and UI are built. What can we do with this state? Naturally, read data from it and modify it. Note that deleting data is essentially a special case of modification. These operations on state constitute management. That's state management. And what's the flow of all changes here? We modify the state, meaning we update some data there. The UI, through one mechanism or another, is subscribed to changes in this state. We don't directly tell the UI in code to update because the state changed. It notices on its own that the state is changed. We'll talk about this a bit later. And it rebuilds itself according to this new data in the state. This is how we achieve consistency between data and UI. The implementation mechanisms for such functionality can vary from the simplest and most obvious, like subscriptions, to more complex and modern ones, like proxies or getters and setters, as was done before as a simpler alternative. In React, this is achieved through building a virtual DOM tree and constant comparisons, along with the setState function that changes state. Angular has a slightly different mechanism using Zone, JS and change detection, plus a relatively new approach with signals, Vue signals, Angular signals, and Solid. JS is built on top of them. We won't dive into the technical details here. I think anyone interested can delve deeper into this later. Let's consider everything conceptually at a higher level. To talk about types of state and how they're divided, and when to use which type, we need to remember that nowadays, development is almost always built on top of components. Each component is a small, reusable piece, a building block from which the entire application is built. This sounds super obvious now, but naturally, it wasn't always this way, and people didn't arrive at components immediately. So let's return to state. What types of state exist and how to work with it properly? Where to put which data, how to monitor their relevance, how to update them, and so on. Each modern framework for developing front-end applications has its own approach to state management. Globally, they're all similar, but they still have their differences. At the highest level, any state in an application can now be divided into two types: client state and server state. Even 5 years ago, there was essentially one general global storage, and server state wasn't distinguished as separate. Now various tools are appearing that allow us to work conveniently with server data and not mix client settings with server ones. Let's talk about this in detail. Let's start with client state and the types it's divided into. The simplest is local state, which lives within a single component. In local state, we store data that belongs only to this component. Using a shopping cart item as an example, this could be data about the selected quantity, whether the item details are expanded, whether the user is hovering over the item, and what size is currently selected. When state changes locally in a component, only that component will change and re-render in the UI. All others won't be affected, but that's in an ideal case. There are, of course, some pitfalls, but we won't discuss them now. Each such component has its own zone of responsibility and its own data. For example, an image gallery would contain state for the currently selected image and zoom level. The second type of client state is global state, that redux we all love so much, in quotes. This is one big storage that holds all the information and data in your application. It's the single source of truth, the data source in your application. Local state can still exist with some small local settings in each individual component, but all data is ultimately stored globally in this state, and components can directly read data from this state. Advantages: you don't need to pass local data from component to component. Sometimes this can be passed through a very long chain, so-called prop drilling. Disadvantages: you get one big global storage that any component can modify. This all turns into a mess. Data flow becomes unclear and disconnected. If you don't have a strict architecturally described data flow in your application, this can backfire later. But again, if we're talking about large applications, in small ones, you won't even notice this. The third type of client state is the most modern, most optimal, most correct one, on top of which you can build beautiful, convenient architecture, modular state. Essentially, it preserves the advantages of global state but eliminates its disadvantages. With incorrect architecture, there can still be problems here. I'll talk about this a bit later. Let's first understand how it works. Here we also have global storages, but not just one, like in global state management, but several. And they're all divided into zones of responsibility. One stores authentication data, another stores shopping cart information, a third stores theme preferences. And components, in turn, read the necessary data from the appropriate modular state. Examples of such modular state managers are ZooStand, yes, I know it's pronounced differently, but I find it easier to say ZooStand, Effector, MobX. In general, you can make modular ones from Redux too if you get a bit creative and write your own wrappers for it all. Of course, like everything in our world, modular state has not only pros but also cons. There are fewer here than in global or local, but they still exist. Again, if you don't have architecture where your data flow is structured, everything will turn into chaos, where components randomly read and write data from this state without logical separation. Let's summarize here. As we've established, client state is globally divided into three types: local, React example, use state; global, example, Redux; modular, example, ZooStand. And let's discuss again what we store in this state, any specifically client settings that aren't related to server data. UI state, for example, whether a sidebar is collapsed or expanded, selected language, current page and pagination, form validation errors, what validation messages to show before the user submits the form, search filters, and similar things. If we generalize all this, these are data that aren't scary to lose within one session. Yes, losing a search query or selected filters is unpleasant but not scary. The user will set them again, and everything will be fine. A good illustrative example: if we imagine that all data in our application is a newspaper, then client data would be the bookmarks, and I think most viewers watching this have already encountered client state in some way. But the biggest question, especially for beginners, is what server state is, how to use it, how to store data there and what data to store there, and most importantly, how to update it. In general, it's not hard to guess from the name. Server state is data that we get specifically from the server. As I said at the beginning of the video, using Instagram as an example, posts that constantly appear in our feed that we need to constantly update on the client, user profiles, story collections, follower counts, comments, direct messages. Some data we need to update more frequently, some constantly in real time, some we don't need to update at all. And we can manage all of this using server state. To better understand the new flow, let's discuss the old way, how it was before. We get data from the server, save it in client state, local or global, doesn't matter much, and all work with this data is conducted on the client. They're changed manually. If we need to update or overwrite this data with server data, we make another request and place it in the client again. We manage the cache ourselves. We also handle loading indication ourselves, some spinner or skeleton, and we save errors in the same client state. So besides doing many manual actions, the problem here is that we mix client data with server data. This often turns into an even bigger mess when it's unclear which is server data and which is client data. The problem isn't just convenience, it leads to bugs. We change some data thinking it's client data, but then somehow in some request, this data flies to the server and changes values in the database that we didn't want to change. This sounds extremely stupid, but it happens regularly, causing a huge number of bugs because work is always done in a team. One person didn't consider something, another person changed something, a third person sent something somewhere, and everything went wrong. Now let's talk about the new flow, how the server state works. The front end makes a request for data to the back end, a standard operation, nothing to comment on here. Next, the received data is saved in a cache using special tools for working with server state, tools like TanStack Query or React Query, SWR, and others. After we save this data, we don't manually interfere with it or change anything inside. We can read this data. Based on what we read, we can create some new data set, somehow modify it for ourselves, and already render this data in the UI. Roughly speaking, this data is read-only, and we can't interfere with changes inside. This already saves us from some bugs. Additionally, we get out-of-the-box handling of loading indications, error handling, and so on. A set of basic operations: refetch by timer, refetch on error, refetch on update, when opening a tab/window, such basic utilities. But what do we do if we want to change this data? Globally, there are two honest ways we can do this. Invalidation. In simple terms, we tell TanStack Query, data in this request is not current. Update this data. TanStack Query then sends another request to the server, gets data, and updates the cache. This way, we get seamless data updates where we don't do anything manually. We only informed with a special function call that data is stale. Invalidate and re-request it. Mutation. These are post-faced PUT requests that change data. But usually after such a mutation, invalidation still occurs. The data we changed is re-requested from the server and updated on the client. Actually, to be fair, you can update data not only through invalidation. Mutation also has built-in processes like optimistic updates. We can actually go into the cache and update it manually, but the only way to do this is through mutation. Here we do it consciously. We know we're mutating data, and we have two ways: update through invalidation/re-request, or, if we want to reduce the number of requests, we can still go into the cache and update it manually. What do we usually get out of the box when using such server state managers? Data invalidation by keys. We'll look at an example after this slide. Built-in polling by timer, e.g., re-request notifications every 30 seconds. Declarative nature. We describe a request, then call a hook like use product catalog, and we know this hook will return data to us. We don't worry about loading indication or saving errors somewhere. We get all this out of the box. Advanced cache work. Optimistic updates, retry on errors, various types of retries, e.g., if you opened a browser tab, re-request data. Basic scenarios like handling parallel requests, pagination, infinite feeds, a set of utilities that further simplify working with server data. Let's look at how invalidation actually works, because it's not very clear in words. Imagine we have 3 requests, all related to order data: get order details, get order history, get order tracking. For each request, we specify the key orders. They're all connected by this key. Then, when we call some mutation related to updating an order, obviously the data in these requests is no longer current because we changed it on the server with a mutation, post or put request, and we need to invalidate, inform that this order's key is no longer current, and data needs to be re-requested and updated. We can invalidate either with a separate function specifically, or in almost all tools you can pass the invalidation key directly in mutations, and invalidation will happen automatically. This way, all requests are updated, server data is pulled, we get current data, UI automatically re-renders immediately, and we get such a declarative approach to working with server data. We don't do most routine operations manually, it's all done semi-automatically. Returning to that newspaper example. In this case, the newspaper's articles are server data. This is what cannot be changed. The base, the foundation. We got this data from the server. It's important it doesn't get lost from session to session. Client data is like sticky notes placed on the newspaper. Press F5, and all these notes are lost. However, they're also very important for the application to work correctly. We need to save form data somewhere, selected filter data, chosen theme, visual components of our interface. Through this separation of client and server state, we don't just divide responsibilities and get declarativeness and convenience. We potentially prevent bugs that we could get in case of inconsistency between client and server data. I've mentioned this many times in this video. That's all, friends. If you're interested in a technical, practical video, for example, on TAN-stack query, covering all its capabilities, showing best practices and anti-patterns, write about it in the comments, because it always seems like the topic might not be particularly interesting or necessary. If I see there's a need for this, I'll definitely record a video soon. If you watched this video to the end, you probably liked it. I'd be very happy to get feedback from you in the comments in the form of likes and subscriptions. That's all, friends. See you in the next video. Thanks everyone for watching.